Seriously happy to be here. This is a special place. We recognize it being very special with the teams that we have working with us. I want to thank the faculty before I forget for the preparation work that you do. I hope you guys really understand that you are in a special place and the preparation you're getting is really second to none. So we look forward to all of the Webbies current and future. So anyway, who's had any experience with marine salvage? Do we at least know what marine salvage is? Show of hands. Not too many. Okay, that's great. I got some work to do here. All right, well, I'm gonna jump in, and I talk fast. I like to tell a few sea stories. I'll try to finish on time. We'll save the questions till the end, and hopefully we have a little fun here this morning. So we're going to cover introduction to marine salvage, a little bit on the business of salvage, which is what our company is. It's a business, a for-profit company. We're going to look at different salvage methods, some case studies, some engineering techniques we use. We're going to look at some of the ongoing things we have going on, and hopefully have a few minutes for questions. So when I look at these slides, I had some help putting these slides together from our Webby team. So when I look at this, and I look at the guy in the lower right, I would say, if he showed up on a resolve job right now, he'd probably get fired for not wearing proper PPE. But you can see how we've evolved over the years to the old guy wearing PPE. But I can remember the days when I was in the chair that you're in now, and I can remember I was a farm kid from Minnesota, went to the Coast Guard Academy, really had no idea what naval architecture was, kind of fell into it because it was a good major, general major for the Coast Guard, and no idea. Even as like a senior, I still really had no idea where this was going to take me. So there'll be some themes. I'm going to build a few little themes in here as we go along, maybe some points to remember, some of my career lessons learned. But I'm going to start with how I started. And my first introduction to salvage was there was a Coast Guard cutter that wrecked up on Lake Superior called the Mesquite. And I just so happened that it was pretty big news in the Coast Guard when I was at the academy, and it was actually an upperclassman two years ahead of me that was at the con when this accident happened. So it's interesting. Look around. One of your classmates could be famous one day. All right. So, but I just so happened that on my senior cruise between junior and senior year, I ended up on a small Coast Guard cutter, ice-breaking tug, and our job was basically to oversee the salvage operation, working with the Navy supervisor of salvage. And it was completely eye-opening to me about this world of work that people do in salvage, and these divers going underwater, cutting and rigging, and big cranes, and all this fantastic stuff. And it was like my first introduction to it. I didn't know at the time that I might end up in a career in this, but it was just a sign. It was like a sign. So as you go through your career and your life, you got to pay attention to the signs. All right, that was one for me. Okay, we're gonna cover a lot of pictures. We'll talk about a few of these cases. Salvage is different every time, and it's largely a complex problem solving in a different place, different part of the world, different scenario. And when I look at these pictures, that's what I see. These jobs that I've been involved with, done by small teams of very capable people solving big problems. And with lots of challenges and lots of struggling along the way. Okay, so another theme is we don't mind the struggle in the salvage business. We're not in the comfort business. We're in the salvage business. But you'll see we'll talk about some of these jobs, and I remember the people most of all when you look back on the career. You remember the teams of people that came together to deal with these problems. So what is salvage? It's a pretty good definition actually that comes out of the International Convention on Salvage. Salvage operation means any act or activity undertaken to assist a vessel or any other property in danger in navigable waters or in any other waters whatsoever. Basically, we're assisting vessels or property in the waterway. Pretty general, kind of makes sense. So what are our priorities that we fall under? And you guys have probably heard these before, but saving lives, number one. And believe it or not, we get, I wouldn't say regularly, but it's not uncommon for salvers to be on the front end of helping folks get their lives rescued. We've had, on our jobs, we've done search and rescue on a job site about assisting casualties. And you remember the Golden Ray casualty, extracting crew members from the capsized Golden Ray. We get regular, definitely not every day, but regularly involved in that aspect. Environmental protection, of course, you'll see over the years the history of salvage, the environment is becoming more and more ever pressing important, and that's a major priority. Restoring infrastructure. What's happening in Baltimore is all about restoring infrastructure as fast as possible, okay? And, of course, saving valuable property. In the original days of salvage, the saving the property part was actually kind of put at the top of the list. Now, you can see how these things have been rearranged. Occasionally, you may find that, restoring infrastructure, sometimes they might actually jump above what's going on in Baltimore. I think that they might actually try to push that higher, right? Some of these super urgent cases. So the reason we're going to touch on the history of salvage, it's kind of important because it forms the basis of how we do our business. The original salvage laws were based on the principle that if you save value in property, the underwriters wanted to incentivize the salvers to go out in the night in the difficult situation and incentivize them by way of rewarding their efforts. And so that's how it all started, this no cure, no pay. If you go out and expend effort and you save our value, then you're going to get actually an award, a portion of the value. That principle still exists today under some of our, we call them our premier salvage contracts. If we go out and save a ship from hitting the beach, we can get a salvage award equal to 1% of the value of the ship and cargo. Now, if you think about $1 billion worth of cargo on a container ship, it can be lucrative, but there are also lots of risk and challenges, lots of expense that goes along with it. But that's, as you go through the conventions, international maritime law, okay, it's based on our IMO conventions. It's still the law that U.S. maritime law is linked to. And most recently, the 1989 Convention on Salvage, it had a lot of focus on the environment. What they didn't want to do is people rushing out to save property and ignoring the environment. So there's lots of safeguards in the system now for us to be incentivized and rewarded for protecting the environment as well. So just interesting history. So we still use these. The basis of this history is codified, and we still use it today. Okay. I'm going to touch a little bit on insurance because that's in our business. We're a business, right? It's driven by these values and insurance, just like you're not totally different than your car insurance, okay? On your car insurance, you have your collision and comprehensive, which is basically what we call hull insurance on a vessel. It's designed to insure the hull value, and if a ship gets damaged, like if you get a fender bender, if the ship gets a fender bender, it's going to pay the shipyard bill, it's going to pay the towing cost to and from. That's hull insurance. Still big numbers. Like a modern container ship or cruise ship can be, a modern cruise ship, very, very big numbers, upwards of $1 billion in hull value. So the values can get up there, but the bigger exposure is on the liability side. It's like your liability insurance, okay? Can you imagine the liability that the Dolly container ship is going to be exposed to in Baltimore? That's a liability that is underwritten by an insurance company. Now they have their layers, and it's an incredible, massive incident with liabilities that I can't even think about. But that's like the mega liability, but you have cases all smaller and medium sized. You have oil spill liability, all these different things. So that's what drives our business is we're typically working for a ship owner that's backed by an insurance company. Either it's a hull insurance company or it's a what we call P&I insurance, okay? There's also one big piece of value on a ship, and that's the cargo. The cargo can be actually way more valuable than the ship itself. In the case of an oil tanker, container ship, container ships that are running around with 20,000 containers on board at $25,000 a piece. So there's huge values in the insurance. So when a casualty happens, all these interested parties come together and they all try to sort out what to do, and that's principal stakeholders of a salvage job. Okay, let's talk a little bit about preparedness because when we think about Resolve as a company, we're kind of a diversified business, but we spend a lot of time and energy on preparedness because when the bell rings and something happens, you don't want to run around trying to figure out what you're going to do. So we spend a lot of time on this part of it. And in the United States in particular, we have an advanced system for response capability, response readiness that was formed under the Oil Pollution Act of 1990. You guys remember the Exxon Valdez? After the Valdez spill, they said, listen, we got to change the laws. We got to basically set up a system to promote response capability, incentivize people to invest in it, and set up like real strict structure. And that's what we have. We have it for oil spill responders. We have it for salvage and firefighting, which is what our company is. So we have, what does this mean? We go around, we set up our network of tug suppliers and subcontractors and all these vendors that support us. We set up depots of equipment. Resolve has 25 depots of equipment around the United States in the form of like mini fire stations, pumping equipment, salvage equipment. And we have, everything is prearranged. We have our commercial charter flights prearranged, all of our people. So how well you do on the preparedness part determines really in our business how well you do when the bell rings. And so you'll see more on that, but that's a big piece of what we do. Okay, the business of salvage, it's some commentary on how we actually function as a business. Now, our company is a privately held company founded by Joe Farrell, currently run by the Farrell family, founded in 1983. All right, Joe was the first guy that I went to work for almost 25 years ago, and the company has grown from the small regional company that I joined to a kind of one of the global leaders in the salvage business. So it's been a fun ride growing the company. But the business, when you think about our business, our paychecks to our people come out of the profits that we make on jobs. So how can you do that? Because you can't predict when the jobs are. Well, as the boss says, if you wanted to have a job where you knew where your paycheck's coming from, then maybe you should be driving a bus or something. But he takes it kind of flippantly. But really, the business is mature. We have diversified parts of it. But you remember that it's made on profits of the work that we do. So how do we diversify that? Number one, you don't do emergency work only. We do a lot of other things. In fact, my job as a projects director is all the non-emergency things that we do. And we'll get into some of that. So we have all our non-emergency project work. And of course, we have the big emergencies. And then we have this preparedness piece, which the compliance part. Our clients actually pay us to be ready to to respond to a job. So that's a piece of it that smooths it all out. And we're still here and growing after 40 years in the business. So just some interesting parts of how that works. We're going to touch on a couple of contracts. I think it's kind of important to know how we do our business. But you'll hear of a Lloyd's Open Forum contract, which is, remember I said the premium contract, the save value, you get paid a percentage. That's what the Lloyd's Open Forum is. It's administered by Lloyd's of London, and it's internationally recognized form. It's a one-page salvage contract. And if you sign that and if you're successful, you may get an award up to 10-15% of the value. If you think about a ship worth $1 billion, that's ample incentive for a salvage company. So why do we run out in the middle of the night for a ship that's on fire, sinking? You do it for the incentive of something like this. Okay, so it's a number of criteria that they assess you when you're done. You say basically you have an open checkbook to spend money on this contract. There's no limit within theory, but they're going to come in the end. They're going to basically gauge your performance when the job's over against a number of different things. The value of what was saved is number one. The degree of danger and risk, number two. Your skill and effort, the promptness, your preparation, how well you were prepared for it. All these things go in determination of what's that percentage of value you get paid. So we like these contracts. They've been shored up by this thing called, remember we talked about the environmental convention? It's shored up by a thing called Scopic, which allows us to, no matter what happens, we can still, even if the ship's a total loss and we don't save anything, we're still paid for our efforts to mitigate pollution. So it's a nice balance. Okay, so you guys probably didn't think you were going to learn about salvage contracts today, but you're learning a little bit. This a little bit more on OPA 90 agreements. This forms the heart of the United States salvage response. Really, oil spill, salvage, and firefighting response. And the United States has the most mature system of all the world. And it's actually a pleasure to work here in the United States because a lot of places you go, they don't have this preparation piece figured out. The other thing the United States has is a thing called the Oil Spill Liability Trust Fund. Has anybody ever heard of that? Basically means that if nobody responds, let's just say the underwriters go, we deny cover, or they didn't have proper insurance, or the guy's bankrupt, whatever happens, there's a huge fund of money that comes off the tax of oil that sits, and the U.S. Coast Guard administers it, and you can actually step in immediately from day one. They can federalize, spend money, and they can deal with the situation. That's completely unique around the world. So most places you go, like we do a lot of work in the Bahamas, the Caribbean, Trinidad, they don't have it. They got nothing. So if something happens, something bad happens, and the guy walks away, there's a ship aground in Trinidad where they don't know what to do. They don't have the resources. There's oil spilling on the beautiful beaches and the reefs. So we have a good system. It works well. There's other countries that are trying to model after our system, but it's a good thing to know. Am I talking too fast? Seems like I am, but no? Okay, all right. We have a lot to cover. I got to get into the sea story part. So, all right, one more slide on contracts. In the world that I live in, we don't do premium contracts. I wish we did all the time. Our contracts on the project side, when you can plan it out, you can bid the project. It's competitively bid against competitors. A lot of work that we do is lump sum. We figure out the cost of the job. We put a single number value on it, and that's it. And so that forces us on the problem-solving side and the engineering side in particular to really understand and figure out the problem and price it all out. And sometimes we don't even know all the variables. So we live in the world of have to be shrewd, very cost-conscious, estimate what everything's going to cost ahead of time, and go do the job. And I'll show you a few examples of those. There's a few different, you hear this term BIMCO? Have you guys heard that before? That's like a standard, what do you call it? It's an organization that administers international maritime contracts, basically. BIMCO. All right, I'm getting tired of talking about contracts here, so let's move into something more fun. Okay, the role of the salvage naval architect. That's where you guys could potentially come in. You guys are growing up to be naval architects. For Resolve, I think one of the secrets of Resolve over all the years is that we've centered our business and our operations and all of our core business around the principle that it's going to be developed from a strong core of technical and engineering basis. Everything that we do is formed in engineering and technical planning. And I think that we stand apart. Resolve has about a dozen naval architects working for us. I think it's probably an order of magnitude more than any of our competitors. We've put this as a basis throughout our history. I started as a salvage naval architect for Resolve, and it's just something that we do, and we do it very well. And we have a big team of naval architects. We have 4 or 5 PEs on staff, and so we train the youngsters coming up, and we basically. But the salvage naval architect joins the project team, and really is part of the management of the team. And you assist the senior operations staff. I tell the NAVARCs all the time, you guys you're going to be the smartest people on the job. Just you are. You're going to have the best education. You're going to understand the engineering, the calculations. The 30-year salvage master may know all the things and gut feel and all the different rigging and cranes, but he's going to go to you because you can't look at a ship and look at the stability. What's the stability? You don't know. It takes the engineering and the naval architecture. That's a key piece of our business. We spend a lot of time training our folks, and they're on every job. Every job, this is a fundamental part of it. So the things that we do, of course, you think about, when I first got into the world of naval architecture, you talk to people and go, oh, what's naval architecture? That sounds so specific. But is it really specific? It's really not. You're going to design this structure, this 1,000-foot long structure. You're going to put it out on the worst conditions of the planet in the open sea. Then you're going to basically build a small city on top of it, and you're going to operate that. And that's specific. That really sounds pretty general to me. That's like the field of study is very wide. Then if you look at our perspective as salvage, then you take that ship and you park it somewhere it's not supposed to be, you catch it on fire, and then you have to bring in a team and deal with this whole problem. Salvage is very general. We pull in knowledge and expertise from all fields, tools and technology, all fields of engineering, and we bring all this to bear, and how well you can bring all these general fields to bear is often determines success on a job. So I love the role of salvage naval architecture. It's a very broad skill set you learn. We learn tools and techniques from all different, we pull them in constantly from other trades. We're always watching for other new tools. So if somebody ever tells you that naval architecture is a very specific thing, then you can defend it. But we certainly do all the fundamentals of naval architecture in preparing our plans, hydrostatics and stability and structures, forces, mooring analysis, and forces on seakeeping. We get into thermodynamics and system engineering. We do a lot of machine design, actually, and I'll get into some of that. Some of our specialty tooling that we use for the ROVs. All right, and the things that you are learning are exactly what we need you to know when you get out there, and that's why we love Webb so much, because they do a great job of preparing you to just jump in and take off running. All right. So here's a few of our Webbies of the past and present. So the guy on the left, Cody Kurtz, I believe is the smartest salvage naval architect walking the planet. He's incredible. He's got like a supercomputer on his shoulders. He likes to get dirty. I took that picture of him. I looked about the same as him. We were crawling through a supply boat that we just lifted up offshore with a saturation dive team and a big offshore derrick barge, and the whole spread was costing us about $350,000 a day. So everybody jumps in. In our business, we get dirty, and in fact, when my big boss gets on a job site, he'll be wearing coveralls and getting dirty with everybody else. That's a part of what we do. We don't do it every day, certainly not, but we promote hands-on mentality, and basically we like to get dirty on occasion. So, And it's not every day you're going to be doing office work and other things, but there's a lot of people getting dirty here. I wish they had showed us a couple clean pictures, but they'll tell them to clean that up. But, I'll hit a few more stories about these guys. I just left Cyprus, where we're working with World Central Kitchen, and Taylor took over that job when I left. Nolan is starting a job, independent project manager. He's leading a job down in southern Chile right now. Mara's on her way to Baltimore if she's not there already, and George is down in southern Chile with Nolan. All right, how are we doing? We're doing good. All right. So let's touch on some salvage techniques and some kind of fundamentals of how we approach different things in the salvage world. It's kind of more for familiarity, and you'll see some engineering in all of this. You hear this term par buckling, salvage par buckling. We want to get the ship typically back on its own hull, no matter what. That's the best place for the ship to be, is upright on its own hull. So a lot of times these ships are capsized, and there's this technique we have called par buckling, which sounds kind of simple, to basically rig the ship and roll it upright. Well, sometimes it's simple and sometimes it's not. I'll tell a little sea story here. Funny how life works out. So where Nolan is starting the job, actually this week in southern Chile, just a few miles, this is on the Straits of Magellan. It's almost as far south as you can get in South America. When Nolan was hired, I called him and spoke to him, hired him over the phone, and sent him to this job, which was just a few miles away from where he is right now on the other job, in extreme southern Chile, Straits of Magellan. This was a ship that was navigating the fjords. There's a little small port off the Straits of Magellan called Port of Natalis. It was carrying trailer loads of cattle and rolling vehicles. And on the chart, there's a whirlpool that's plotted on the chart. And it says, at spring tides, it's 12 knots of current. He was they mistimed it, trying to get through this cut. And the ship, literally at full power, failed to make progress, and it bounced off the rock next to it, and it ends up capsizing in this fjord, middle of nowhere, southern Chile. And believe it or not, a few of the cattle in the process of sinking got out of the trailers, open top trailers. They're running around, and they're sort of trying to round up the cowboys to round up the cattle and out of the neighborhood. And then the ship ultimately sank. And what you don't see, I wish I had time to, this is like a whole case study in itself, but it was sitting on this cliff wall with the stern of the ship in 100 meters of water on this precarious little precipice that was sticking out. And so, okay, what do we do with that? So it's a problem. So this problem starts with naval architecture. Okay, that's how we start solving the problem. How are we going to deal with the ship? Now, granted, it's got all kinds of other factors, environmental factors and location. How do we get there? And it was 35 miles away from the closest small civilization. So the naval architects got together, and this is what they came up with. Okay, I don't know if I was part of that or not, but you can see how this is basically a par buckling setup for this ship to get it upright. And we won't go too far into it, but all the lines that are attached to the rocks are basically holdback lines to keep the ship from slipping off the rock as we rolled it upright and refloated it. So all that complex system, we had to drill anchors into rock, 4-inch concrete anchors that went into the rocks. Complex setup, 2 barges, this complex lifting system. So that's it. We can't do anything until we understand how we're going to do the job. So that's kind of what salvage naval architecture starts out with on these jobs. Here's a picture of the whole spread in place, 2 lift barges, 1 on each side. You'll hear this thing of, we use hydraulic chain pullers for lifting. They're 300 tons apiece. We can send them down in containers, and we can set them up. We had probably 10 on each barge, and you can lift 3,000 tons off of each of the lift barges. So it's kind of the principle we'll use, and you'll see it more in a few other jobs, but that's what the whole setup looks like. Now you have to get everything there, of course, and get it all set up. It takes a lot of effort. When I look at this picture, everywhere on the deck I see engineering. Okay, everything is welded to the deck as engineering. Okay, all the rigging is engineering. The equipment placement, the layouts, the rigging of the ship, it's all done by the naval architects. Just a few more pictures. The job went well. One of the concerns we had when we went down there is that there was a number of the cattle that died inside the ship. So that's a problem. What are we going to do with all the dead carcasses of the animals? So we'd spend a whole bunch of time, we bought this giant 40-foot container incinerator to send down there to deal with the carcasses of the animals. We got there, guess what? Nothing was left. The crabs and sea life, it was just nothing but bones. So that was a small victory. All right. Okay, so sometimes you just have to lift. You have to just put a lot of lift force on things, all right? And so our same chain pullers, the two bars on each side with the chain pullers in the lifting configuration, that we use that a lot. This picture on the left was an Indian submarine actually that blew up in the port of Mumbai loading weapons. 28 sailors lost their lives on this thing, unfortunately, tragic accident. The good thing is that it was the middle of the night before they were going to sail, and everybody else was at home because everybody that was on the sub from front to back perished. So it was, remember the Kursk submarine that had the liquid oxygen torpedo problem? We believe it was something similar. We don't know for sure, but it blew, massive explosion. It blew the sub up front to back, and it sub sank in the harbor. In the Mumbai harbor, there's nothing but soft, silty mud. It was like 5 to 8 meters of mud. So there was mud around the entire submarine all the way up to the conning tower. So dealing with the mud's a big problem. But we basically got rigging underneath, and we did a deadlift with our chain pullers, and we ultimately carried it over to the dry dock and put it in the dry dock. The one next to it is a massive offshore derrick barge called the DB1 that we did in the Gulf of Mexico. Heavy lift, 6,000-ton lift, similar method. I think I have a few more pictures of that. That's what that one looked like. You know, crane. We like big cranes in the salvage business, but you just never have a big enough crane. That crane barge you see on the top there, 1,500-ton revolving derrick barge. Yeah, but the wreck weighed 6,000 tons, so it's not big enough, right? So what do you do? We like our portable systems. We had 10 chain pullers on each barge, and we set up a 6,000-ton lift. We lifted it up. We floated over the top of that. That was a submersible barge that we set down on the seafloor, and picked the wreck up. So we believe that's the heaviest salvage lift ever made in the Americas. So that's naval architecture. All right. Well, a slightly more technical. This you guys might appreciate. This is. You hear this thing called compressed air dewatering in our business. It is one of the most powerful tools that we have in the arsenal, okay? It's the ability to use something as simple as compressed air to apply massive forces to a wreck underwater, all right? What's the best part of it? You can't get any cheaper than compressed air. It's like super cheap. You don't need a big crane. What's the worst part of it? It can be like completely uncontrollable, like blow up and like wreck your whole project if you don't manage it. So the risks of it has high risk, but it's a very, and so what we've worked on is a system to control this technique in very highly sophisticated ways, so we can apply it. Let's give you an example. So if something sinks, like say a barge were to sink, and if it's down 20 feet, all right, and you want to pump the barge out, so you run a vent hose to the surface and you turn on the pump. What happens to the pressure on the barge? You guys heard about pressure head, hydrostatic pressure head? As soon as you start the pump, start drawing atmospheric air into the barge, what happened? You spike the pressure head is the full depth of the water. And structures, marine structures are only designed for so much pressure. And 20 feet is probably about the limit. That's going to be at times 0.445. So you're going to be at approaching 10 psi. It's huge pressure. 10 psi on a structure is crazy. It's getting up there. So, yeah. So what happens if you do that? You start your pumps. You just collapse the structure, collapse the barge, and then you got nothing. Then you got a piece of scrap metal, and the client's not going to be too happy. So this tool, instead of turning the pump on, what we do is we pump air down into the structure, and it automatically balances. So you start with zero hydrostatic pressure. You start with zero differential, and you start from there. So it's a wonderful tool. So you just eliminate all this. You can do it at 1,000 meters. You can pump air down if you wanted to. No pressure, but what happens if that thing were to jump up through the water column? All that air wants to expand, and now you got the 10 psi on the inside wanting to blow the structure up. So that's the controllability factor that we use, and you'll see some of the structures that we've done this with. It's just very common on grounded vessels where the bottom's tore out and you have a good deck like a barge. It's a great kind of a structure to use this tool. You could have the whole bottom of the barge could be tore out, and you could refloat it on air. So works pretty well. This is a job we did in Freeport, Bahamas, 80,000-ton deadweight or capacity dry dock, 900 feet long, and it broke with a cruise ship on it. You might have heard about it. It was a Royal Caribbean cruise ship on it, 250-foot wide dry dock, went like this, broke like this with a ship on it. Big problem. Thank God nobody was killed, but basically it just They were actually trying to lift a ship that was heavier than the dry dock would allow and put the stern of the ship in cofferdams, and they were basically just maxing out the limit of the dry dock, and things happen when you're trying to do non-standard things. So, but we got involved. So you get this thing that the steel was like 25,000 tons of steel. It's broke in the middle down the whole thing. The whole watertight integrity's wrecked, everything. So what do you do? How do you get rid of it? What do the competitors do? They say you got to cut it up in pieces and pick it up. It take you forever. Cost you $100 million. So how does resolve? Our secret is creative engineering, problem solving. Let's look at that problem and come up with a better way to do it. And we use the compressed air dewatering tool and to basically capture compartments. It was, the bottom of the dry dock sitting in 80 feet of water, so massive hydrostatics. We used it and come up with a creative plan. And the first thing you can see we decided to do was we didn't want to deal with 900 foot of dry dock. We only wanted to do it like 450 feet because it was like too complex to do the whole thing. So we cut it in half. And we did the sections one at a time. You might see this dry dock later on in the presentation, but you can see the jagged cut line. That's actually we call a chisel, a guillotine cut line. I'm going to talk about that. But if you look on the left side, you see that wrinkle all the way down? That was the buckle. It was fully hinged at the 3/4 point. And the beams that ran across the deck, they were just compression beams that we were able to squeeze the dry dock against the beams and just carefully lift it. They weren't there to restore the structure, but just give us a stop point that we could collapse the wing wall onto that point, and then we could lift it from there. So it was a cool job. All went well. Every one of these jobs has its own anxiety and stresses, and I can remember a few long nights over there with the guys. But is that naval architecture? That's absolutely salvage naval architecture. Another good example, this was an fully loaded oil barge that capsized. This is after Hurricane Katrina. Most people don't remember this barge because it happened after Katrina, but if it hadn't been Katrina, it would have been like international news because it was full of oil and it sank. We actually used compressed air, refloated the barge upside down. We actually pumped the oil out upside down through the vapor manifold to lightering barges and basically refloated it and towed it into Mobile upside down. But that great. So those closed compartments control the air going in, watch the pressures very carefully, right? As it comes up slowly, everything's slow, and it's, no cranes. We did this whole salvage job with just compressed air. We set a couple compressors on the boat alongside until the barge was sort of level. Then the entire team went on the top of the barge. We just kept on going. All right. We do it's amazing how many ship fires that we respond to anymore. Ship firefighting is just, I think it's because of the vessels and the cargo's getting complex and the container cargo's are complex. Ships are getting larger. There's a lot of ship fires happening, and we do a lot of firefighting, a lot of ship firefighting. So we have, this takes its own separate strike teams of people and the special fire equipment and our depots, but we do a lot of this. We consider a ship fire to be a salvage problem. Do you know why we say that? If you bring a firefighter to a ship fire, they're going to think like a firefighter. And what are they going to do? They're going to, number one, if you bring a municipal firefighter, first thing they're going to do is like try to knock all the windows out and open it up and ventilate the thing, and then you have a raging fire, and then they're going to pour as much water on it as possible until the ship sinks. I'm not joking. That's exactly what happens. So if you think about all the municipal fire departments that are responsible for ship ports and ship firefighting, there's like over 1,000 of them. They're just never trained enough. They're just never understanding the problem enough. We constant training. So for us, the first guy that we want on one of these jobs is a salvage master. This is a salvage job because it's you got to solve the whole problem. You can't just solve the fire part. You got to solve the whole problem. Everything around the ship. How do we get so we think about how do you get the water off the ship before you start pumping to put out the fire. All these things you have to solve the whole problem. Is a naval architect part of this business? Absolutely. Okay, we do a lot of we call them subsea fuel removal jobs. If you look at at a map of all the wrecks around the coast of the United States, really the coast anywhere, there's a crazy amount of World War II wrecks. These old ships that were sunk, full of fuel. Some of them are tankers transporting heavy fuel, sunk. They're just sitting out there since World War II. And the ships are getting old. They're starting to leak. And if you take a ship and you turn it upside down, that hull is like a perfect boundary for keeping the oil intact. This oil comes out of these ships, where are we at? We're, 60, 70 years later, it's like the day it went in the ship. So when these ships start leaking, we've done a number of these jobs where you got to get the oil out of this ship before it dumps its cargo. And there was one we just did off of Long Island called the Coimbra a couple years ago. It was a tanker. One of the first ships sunk after World War II started, when the German submarines started sinking ships leaving New York Harbor. One of them sank, and it sat there with a tanker load of cargo for all these years. And then we got the contract with the Coast Guard to go suck the oil out of this tanker. So it's kind of cool work. It's done with a lot of technology, a lot of ROVs. We can do completely ROV only, but if it's shallow, the divers sort of help speed it up. But this is some of our jobs, so subsea fuel removal jobs. Work-class ROVs are like essential on every one of these jobs. Because work-class ROV is like the size of a small car, and it can be a couple hundred horsepower. Anybody guys familiar with ROV technology? Anybody? Yeah, they're very cool tools. Yep. So our part of it is that we don't want to own a work-class ROV. They're very expensive. We want to own the tooling, the specialized tooling that we can rent an ROV and they can deploy our tooling. So we're constantly developing tooling. We have a new ROV, deepwater ROV system, high capacity, that's being finished in Houston right now. And so it's just kind of a niche. You talk about our business as Salvage. This is a core niche of what we do. It's fun work. It's good. Obviously great for the environment, getting rid of this oil. All right. So let's talk a little bit about my world of wreck removal. We do a lot of shipwrecks, removing shipwrecks around the world. And of course the shipwrecks come with all kinds of environmental hazards. And the first thing we do on most of these wrecks is deal with all that residual oil and clean the ships up. But then you have this big chunk of steel sitting someplace. Usually it's like remote. It's always remote. And you have to deal with it. So one of the things that we spend a lot of time on is how do you efficiently section that ship up so we can come up with some creative technique to get rid of it. If all the other techniques work, it's like compressed air is not going to work on this one. It's like mostly out of the water, right? We got to come up with something else. So ultimately, a lot of these jobs, you have to just section that thing up and get rid of it. So just like down in Baltimore, they're spending a lot of time thinking about how to section riveted bridge structure right now. So we spend a lot of time on these techniques, and so we have, of course, a topside cutting. We still do a lot of topside cutting with guys in torches. We do the guillotine cutting. I'll have a slide on that. That's basically dropping a big chisel, heavy, like a 20-ton chisel on the wreck. Chain cutting, if you guys ever hear chain cutting, we can pull like a 3-inch anchor chain back and forth under tension, and we can rip it right through a wreck. That's very efficient, but you have to have very big tools to do that, which we don't always want to bring because they're expensive. There's, of course, diver cutting. The exothermic divers can cut through just about anything underwater, but they're slow, and it's expensive. Diver time's expensive. And then there's new technology, diamond wire. That's sort of diamond wire sawing. It's pretty effective, but it's got its own little niche of when it works and when it doesn't work well if the steel's going to bind the wire and different things. But so these slides are that same ship coming apart with topside cutting, and the easy button in Salvage is to just bring the big crane, the big sexy toy, the big tool, but it's not going to get the job, right? It's a competitive business. We want to come up with a creative solution that is most cost effective, that reserves the most amount of profit for us and beats the competition. So you come up with all different kinds of ideas to do that. And one idea, we had those chain pullers we talked about. You see them sitting on this foredeck. We actually ballasted the complete hold, number one, and we used the chain pullers to lift the pieces out of the water. Cutting above the water, very easy, right? That's just a guy with a torch. Below the water, very difficult, right? How do you deploy the cutting below the water? So we want to get the pieces out of the water. Now, it should be a little bit more aligned, but a big storm came through and pushed everything out of alignment, but we still managed to get it done. But you can see how, these creative, so with just a basic crane barge, we were able to section up and remove this whole wreck. This is that guillotine blade we talk about, like a 20-ton drop chisel in a guide. It'll cut through just about anything except like a big shaft, right? It'll hit. They're very impressive. It's like brute force technology, and it's sort of like 100 years old, but sometimes it's just nothing beats it. That's called the guillotine. It's a job we did off of down in Namibia, the skeleton coast of Namibia. This big cable layer caught on fire and wrecked down there. You can see this was a big pulling job. Instead of lifting, sometimes you got to drag the structure or pull the structure. So we set up on the beach. You can kind of see those chain pullers are set up on big anchors that we buried in the beach. Built a small jetty out to the ship, connected to rigging, and we did a pull of this 6,000-ton ship to the beach. This is like another middle of nowhere jobs. Namibia, fantastic place, really unbelievable, just beautiful place. I would love to go back, but it's the second least populated country in the world. If you're an introvert like me, very fun place to be. So anyway, that's see our chain pullers now being applied in a pulling fashion, not a lifting fashion. All right, we're going to do a little video.
To assist during this
This is the owner of our company.
We were brought in when the structure became critically stressed during the dismantling. Before we dropped the bridge, we put down 20 lengths of 3-inch chain. These chains will be connected to the two lift barges, to their chain pullers.
It's just up the Hudson River, about 4 or 5 years ago.
And in this scene, you're going to see 2 spectral lines connected to the bridge that in turn connected to 2 chain pullers. Each chain puller was pulling at 200 tons for a total of 400 tons. We did this so that when the bridge collapsed, it didn't fall or waver back into the navigational ship channel. In this clip, you'll see these brand new equipment on the bridge. The bridge was so unstable, we were afraid to even remove that weight of equipment. Because the environment is always number one in Resolve's mind, right after saving lives, we made a point to get all the oils we could to fuel a lot of these machines. So we ran all the oil out of the diesel out of these machines before we dropped the bridge to avoid any environmental pollution at all. Another and one of the most significant challenges was how to drop this bridge with explosives and not damage the almost $4 billion new bridge immediately beside it. Now that the tricky part of the job is sort of behind us, comes the real challenging part of removing it. So we're looking at 2 300 by 100 foot barges rigged with 10 chain pullers each. The lift barges are basically the size of a football field, each one. The chain pullers themselves are Resolve's proprietary equipment. We've actually built, designed, and patented these units, as we do most all of our other salvage equipment. This bridge section is 10 lanes wide for traffic and 650 foot long. The lift of the Tappan Zee Bridge, although only 4,500 tons, is going to be equally as challenging as the DD1, given the clearances between the lift barges and the bowl barges.
That was the same barge, submersible barge we used on the other job.
Most vessel, when the wreck salvages and things of this nature, there's always more to the story that meets the eye. We've had some tremendous concerns with the ice. We've had Arctic vortex came in, froze the river. We've had to hold the lift operation a few times with the ice in the river. Once we raised the submersible barge to the surface, we found that it would be more cost effective to tow the barge, the submersible barge, with the bridge on it, put it on all the way to Freeport, Bahamas, and cut it up there versus doing it up in New York. And above that, with a good lot about get us another safe operation.
All right, that was, cutting techniques. Sometimes shape charges are your best friend. So that's being discussed in Baltimore as well. I'm watching the clock. I've got a few things to finish. Roller bags, you guys seen these before? These launching roller bags? We use them all different configurations. They're very slick. This was the fishing boat fleet over in Fort Myers after the hurricane a couple of years ago. About 40 of these fishing boats that we put back in the water for the state of Florida. The roller bags were very useful. Let's see. Just a few more pictures here. More jobs. That one in the center is an Indian Navy frigate that capsized in the dry dock after they were lifting it off the blocks, refloating it. They basically removed the shafts, some machinery, basic stability problem on coming off the block. She rolled right to her side, loss of negative GM. A couple more sailors lost their life. So this was after the submarine job, so they called us like immediately, and they said, you got to come to India, and we're like, okay. So I literally grabbed my go bag and I head to the airport. Now if you go to India, you got to have a visa. And India is lovely people in India. I have a lot of great friends there, but they're very systematic, bureaucratic about how, the place. And so you don't go to India without a visa, even U.S. citizens. So it takes a process. It doesn't take very long, but I had to go. The thing was going, so I went straight to the airport. I talked my way into the airplane with the press release saying, look, I got to go. They're like, well, they're not going to let you in when you get there. I said, well, I got to go. So I land at like 2 o'clock in the morning, and they dragged me back into immigration, and the senior immigration guy comes out, and he's like, you're going back home on the next plane. And I said, in a very nice way, I said, sir, Mr. Pujari, that ain't going to happen, okay? and if you try to do that, if you like your job, you won't do that, okay? So here's a phone number. Call this guy in the Navy. The Navy commander happened to be sleeping in his office, thank God, when they called him. He's like, yeah, Schauer, we need Schauer, get him over here. So he comes back. Next thing I know is this guy comes out carrying a little plate of tea and cookies, and I'm like, oh, okay, great, I must be staying. So, but then he calls in the airline guy, sits him next to me, and he writes him a $5,000 fine for allowing me to get on the airplane. I'm like, hey, he's like, you just sit there and like drink your tea, eat your cookies. So. There are so many stories, humorous stories in this business. It's really you got to have a sense of humor. So I'm just going to touch on a few things we got going on right now because it's kind of cool. This is a job we're doing in Cape Town, basically Port Elizabeth, South Africa, a few miles away. It's a big fishing vessel wrecked, completely unaccessible place as far as like any kind of floating equipment, big swell. Coming in, it's actually on a place called Shark Point. So if you guys, South Africa is known for white sharks. Well, this is Shark Point. So we're taking it apart with taking all the debris and all the hazmat off with helicopters, taking the steel off with a helicopter right now as we speak. So kind of a cool job. This is kind of just a few slides on I spent 3 weeks in Cyprus and setting up with World Central Kitchen this maritime corridor to get aid into Gaza, and fingers crossed, you'll keep hearing about that in the news. I can't talk about it a lot, but it's Resolve's kind of the primary partner of this NGO to get this aid flowing in advance of this larger military plan. So that's, of all the things I've done at Resolve, it's been feels pretty important. So we hope that gets rolling. Just a few more things. We do a lot of work for SpaceX. So it's kind of cool. This was some feedback from SpaceX. I look at SpaceX as like a really out there problem-solving company doing crazy things. And so when you get good feedback from SpaceX, it was pretty. We helped them with this tricky project. This is the project that Nolan's on right now in Straits of Magellan. That wreck removal he's doing. And you guys have all seen that one in the news. That's a big problem. I can't talk about that one either, but that's a big, complex salvage problem. There's going to be plenty of naval architecture going on down there. The only thing I took notes on is this last slide. So I have 2 daughters in college. A lot of them, one's just started and one's a little older. My youngest daughter changes her mind every week about what she wants to do. I'd love them to come here, right? But all they've seen their whole life is basically ships on fire, ships wrecked, and ships sinking, and so they're like, Dad, we want nothing to do with shipping. That ain't happening. So, but as you go through your life, I can remember sitting where you're at going, what am I going to do? What am I really supposed to do with my life? And so I've got a few thoughts I'm going to finish on here. First thing I would say is, dream big, okay? Visualize the best version of yourself that you can possibly imagine, and refresh yourself on that every day, because that visualization is very important. That can happen. Number 2, be bold, okay? Be bold in your career. Chase adventure, okay? Chase meaningful purpose. Don't chase comfort. Okay, we don't chase comfort in the salvage business, as you can see. Don't chase comfort. Don't chase the dollars. The dollars will come if you work hard, okay? Challenge yourself. Embrace the struggle, we say. Like, through that struggle, you learn and you grow. That's what causes you to grow faster when you're in those stress. You got to get out of your comfort zone a little bit. On the network side, you got to forge, I'm an introvert, but you forge these lifelong relationships when you get into the struggles that you're in life and the things you do. People around you, I guarantee you these people will be a part of your lifelong network, and relationships are super important. I think about my salvage career, all these people I've met, my friends in India, all over the world. And once you meet and forge that, you have that forever, okay? So that's really important in life and in business, okay? And the final thing is, don't worry. You guys may be looking ahead like, I have no idea what I'm supposed to be doing, who I'm going to be working for. You guys are on a perfect track, okay? Pay attention to the signs, okay? There will be signs along the way. Pay attention to the opportunities, and I promise you that's what I tell my daughter like once a week when she changes her major. Like, just pay attention to the signs. It's all going to be fine. Have fun along the way, okay? Have a sense of humor. Thanks very much for the time. I appreciate it. I have time for questions if anyone wants to chit-chat later. I know it's lunchtime, but thanks for your attention.